wa pa ko yung final record sa inyong grade. So, basin, Friday pa yun ako siyang upload na or 23, no? Since maman po na mo ang deadline for posting of grades. Right. Okay. Ay. Okay, so for part 1, no, we have here true or false. Dali na ako ibalik na lang sa PDF, no? Um, so, the instruction is right stress if the statement is correct, and if it is incorrect, then right string. So, klaro kaayo siya na instruction. Dili true or false ang inyahang isulat. So, for those na nag-answer true or false, wala na ko siya i-consider. Okay, for number 1, tangential stress differs from both tensile and compressive stress in that it is caused by forces along or parallel to the area resisting the forces. So this is stress, no? This is actually true. Then, bearing stress is the contact pressure between two separate bodies. So this is also true or right stress, no? Then number 3, torque is a moment that tends to twist a member about its longitudinal axis. So this is also stress. And number 4, tangential stress and circumferential stress are the two types of stress developed in thin-walled pressure vessel. So this is strain. False na siya, no? Tangential and circumferential stress are actually the same. So for number 5, strain is defined as force per unit area. So this is also strain. False kaya po niya, no? Sige, so for problem solving, situation 1, we have here, ako na lang siya i-copy. The steel arm is loaded as shown. Determine the required diameters of the pin at C and C, and at A and C rather, no? If the allowable shear stress for the pin at A is 8 KSI, for that for pin at C is 10 KSI. Okay, so gitagaan taog allowable shear stress for both pins, no? And we are to determine the required diameters, no, for each of the pins. Sige, so ato lang i-copy ang figure. Wait, siya mag-copy. Ano na lang. Okay. So, saan matter na siya, no? First, of course, we have to determine the reactions no, at points A and C. Kay mo-order na siya to ang basis sa pagkuha sa ato ang required area no for each of the pins. So you have to determine kung how much ang gina-resist ang pin para makuha po nato kung pila po ang iyahang required na diameter. Since di ba we have an equation for shear stress that shear stress is equal to force no, per unit area. Since kitagaan mataog allowable shear stress and ang required is the area no for pins at A and C. So of course we have to determine iyaha lang actual load na applied or ang iyaha lang resisting loads ana siya nga point or support. So analyzing our figure, ato i-draw iyahang free body diagram. So this is point A. And then point C. So this is spin supportive ba, meaning isa ra na ang iyahang reaction, di ba, din ha, since we know that pin supports only have one reaction and it should be perpendicular na sa surface. Ani. So that's why ina na ang orientation sa imuhang force no, at C. So ako siya i-label as RC since ato man na siyang i-resolve into X and Y components para mas dali na to siya ma-analyze. No? So if ato na siyang i-resolve into X and Y, you have this CY and CX. And then you have here 3.5 and also an inclined force. No? So na inclined force that is 30 degrees with respect to the vertical axis or to y-axis. So this is just 7 kits. Okay. Sige. So, mas simple if mag-moment tanaw at point C. Since this is a pin support and they don't have resistance to moment, that's why we can actually sum up moment at point C equal to 0. So, if mag-moment akang point C, ang unknown na lang din sa to ang system or sa to ang structure would be the force on point A no, or at support at A. So, meaning, makuha na to ang reaction kang point A if mag-moment akang point C. So, taking moment at point C equal to 0, having counterclockwise as positive, then we have this. So, AX will cause counterclockwise, no? So, this would be positive sign convention. AX times, so, iyahang moment arm would be 12 inches. So, si 3.5 na force, so that would create a clockwise rotation with respect to point C. That's why it will have a negative sign convention. 3.5 times, we have this, no, 6 inches yung moment arm minus, so ato lang siyang i-resolve into Y component, no? O na to yung Y component. Think, wala man siya X component, kay that will just be equal to 0, kay ang X component in 7 kicks na force is acting along point C. So, wala kay masam ang moment, no, at X component of 7 kicks. So, Y component lang ato ang makonsider sa iya, ha. So, 7, this would be cosine 30 degrees, no, times iyahang moment arm would be 6 plus 3, so that's 9 inches equal na to 0. So, therefore, makompute na to si AX directly, no, since in this equation, siya lang ang anong sa to ang equation. And how much is AX? This would be 12 times AX minus 0.5 times 6 minus 7 cosine 30 times 9 equal to 0. So AX therefore is 6.297. Okay? Now, ato na po i-solve ang reactions, no, at point C. So, to do that, ato man ang i-resolve, diba, into X and Y components para mas dali na to siya analyze. Then, we just have to compute for the resultant or the magnitude of the resultant of your force or reaction at point C, which is Ty squared plus Cx squared. And that would be your total reaction at point C. So, In getting the components, no, so mag-sum up lang to of forces on X and Y components. See. So for summation of forces on y-axis equal to 0, diba you have Cy upward and isa pa man to, si 3.5 no, downward and minus 3.5 and also the y component no, of 7 cubes. So, in this equation class, isa lang po ng ato ang unknown variable, meaning, makompute na to directly si Cy, and that is, pila man ni siya? 3.5 plus 7 cosine 30, that is 9.562. So how about for Cx, no, or the x component of reaction at C? So solution of forces on x component, you have here, so CCF itself, which is right side ihang conventional, so positive, minus AX na going to the left, plus also the x component of 7 cubes, diba? Kani siya. So, ma-include na ang x component sa mga 7 kits since we are analyzing forces noon. X component. Wala ka na po ka-old moment. So, this would be plus 7.5. Sorry, is it? It's only 7 bits. So, y component to 7 sine 13 equal to 0. So, since AX is obtained, di ba? And it is equal to 6.297 kits, so ma-compute ra po nato si CX. So, CX were, therefore, pila man siya, 7 sine 30, so Cx is equal to 2.797 kips. Alright, so we now have the component na of the reaction at C. So, makompute na nato directly ang iyahang magnitude, no? Or total reaction at C. So, it's just Cx squared plus Cy squared. RC therefore would be, kailangan na siya, square root of 2.797 squared plus 9.562 squared. RC would be equal to 9.962 kips. So we now have actually the data, no, that is needed to compute for the required diameters at A and C. So unahon nato analyze si pin A. So for pin A, since the equation for shear stress now is just force over area, and you have an allowable shear stress now for pin at A, that is 8 KSI. equal na to PA, no, or the reaction at point A or at pin A. And di ba mo naman na siya si AX? So si 6.297 kips. All over the area, no? And since mga pin man ni siya, no? And stated na diameter, so circular ang ato ang pin. So it's just pi over 4D para makuha niya nato diretso ang iyang diameter. Therefore, the diameter no at pin A or the required diameter at pin A would be yeah, it's 1.001 inch. So take note that the pin no at point A is just subjected to single shear na condition. That's why our analysis will just be in this manner. However, for point C or a pin at C, so it times 2 na to ato ang area no? Since it is subjected to double shear man daw ko na ato ang pin at C. Okay, so allowable stress at pin C is equal to the reaction or total reaction at pin C all over 2A since it is under double shear na condition. So, pila dito ato ang allowable shear stress for pin C. We have 10 KSI. Equal now to the total reaction at pin C, that is 9.962 kips. Over 2 times therefore the required diameter at pin C that is subject to double shear and has an allowable shear stress of 10 KSI would be so we have here 0.796. Okay, so that would be our answers no, for situation number 1 ng problem. Therefore, the required diameters for pin A and C are 1 inch and 0.796 inch respectively. Okay, so na to ang final answers for situation number 1. So I think daghan man siguro nakako ang nga problem no. So I'm happy na nasabtan na rin siya nga concept or fundamentals. Sige, so proceed to with situation number 2. So, for situation number 2, no, I think the majority of the students naglibog. Situation 2. Okay. Although, nakita na ko nung na ay nakasabot sa concept. It's just that nalaga po kalipugan no, at some points sa solution. So I'm not sure kinsa to na student ang nakuha sa concept ano. I forgot the name. But actually gamay ra gyud sila ang na ay almost correct na answer for situation number 2. Anyway, so for situation number 2, we have here the truss is subjected to deloading shown. If the allowable normal stress in member BC is 120 megapascal, determine the required cross-sectional area in terms of millimeters squared no, of member BC. So actually, ang lagi hapon approach ani is the same no with situation number 1. It's just the same concept. So for situation number 1, if shear stress ang ato ang consideration, here naman no, for situation number 2, allowable normal stress ang ato ang i-consider no, restriction for our design. And di ba, the equation or the formula for normal stress is just the same sa shear stress nga P over A. So ang ipangita diba dere is member BC. So asa si BC mo diba na siya? So kanina number ang ato ang pangita of required cross-sectional area. So wala siya nang ingon nga diameter or length or width. So ato lang as is na ato answer as area no for member BC. So regardless of the shape of member BC, so we are to provide the required cross-sectional area of member BC. And how do we do that? So again, the same approach actually, no, equation number 1. Ato siyang i-analyze ang given truss. Sige. So, to analyze our given truss, no, so first step, di ba, ato lang i-determine ang reactions at the given support. So, at point B, di ba, you have pin support or is pin support. So, one reaction lang na siya, no? And then at support A, you have hinge type of support. So, we know that that has two reactions, no? And since normally upward lang ato ang reaction no, at hinge support, that's because of the nature of the external loading na apply sa structure. So in this case, since we have an inclined force no na applied, so mag-generate ko na siya og X and Y component no. Therefore, your reaction no, or your support at point A nag-generate po na siya og X component na reaction no? And since this is hinge man, so it is possible since it has two reactions, di ba? Ang ato ang hinge support and CG. So to determine the reactions at supports, so moment lang no, at either points or at either supports. So ang ako ang approach ani no, or ato ang approach ani sa tong analysis would be ani siya no, ato ning I solve using method of section no. So from statics of rigid bodies, diba, you are taught on how to determine the internal reactions no at each member sa imuhang truss or sa imuhang structure. So diba, we have two available methods for that. We have method of joints or method of section. But in this case, mas easier actually nga method of section ang ating buhaton. So if mag-cut ta ani nga part no or ani nga plane sa to ang structure. So AA, ako na siyang i-label as section AA. So atong i-plot si section AA. So considering right side part na of the cut plane or cutting plane. So that would be the point B. And ang iyahang reaction no, or siya i-label as RD. And then, so kinsa man nga members ang nakat mo. So si member FE. So this is FE. And then si member FC also. And also si member BC, no? Eventually si member BC, which is the essential part sa to ang solution. Okay, sige. So assuming tension tensile under tensile panel, no? So this is, di ba si FC, si FE, and si BC. No? So ang atong goal is to determine the internal reaction lang at member BC. Kaya siya naman ang ato ang objective sa problem. So determine the required cross-sectional area of member BC. So siya lang ang ato ang concern. So dili na nato need ang data for member FE and member FC. So dili na to siya analyze on. And to do that, so mag-moment ka kang asa man nga point. So if this is point C, point D, and point F at this point, so mag-moment ka kang point F, di ba? Anong moment man ta kang point F? That is because if kang point F ta or kang joint F ta mag-moment, ma-cancel ang imuhang two unknown variables, which is si FE and CFC, no? Kaya they are acting directly at point F man. So if moment ka pang point F, ma-disregard na siya no, sa itong analysis, which leave us with one unknown variable na lang, which is si BC. And since siya man ang atong ang goal, di ba? Or atong ang objective in this problem. So it is much convenient or mas efficient sa atong part if kang point F ta mag-moment. Although you can actually use method of joints for the, you know, so analyze ka kang joint D, kang E. So kang E ka mag-analyze after point D, no? Because if kang point C ka na after point D, you have three unknown variables. Di ba? Si DC, si FC, and si CE. And then ang imuhang obtained internal reaction lang aning analysis ng point C would be CCD lang. And the equations of equilibrium, hindi sila sufficient no, enough to solve these three unknown variables. That's why if nagamit ka og method of joints, una ka kang point D, and then sunod ka kang point E. Kay at point E, obtain naman yung si DE. Obtain naman na nimo siyang internal reaction since na-analyze na nimo siya from point D pa lang, no? So meaning at point E, ang imuha lang concern or unknown variable would be FE and CE. So duha lang, no? Which is masobra po nato by method by equations of equilibrium, you know, summation of forces on x and y axis. And then after joint E, I have pa rin ka maka-analyze from point C. Kaya na naman kaya obtained data for CE and CD, di ba? So yung mga analysis na yun kang point C, masolve na mo siya since duha na lang ang unknown variable, si FC and si DC, di ba? So mo taas ang solution if method of joints. But if you are comfortable using method of joints, so okay ra gyud kaayo na siya, no? As long as makuha lang gyud nimo ang internal reaction kang number BC. So that's just the goal, no? Wala gyud ato ang goal. So anyway, pwede po ka mag-start ng number or rather kang point A, no? Pwede po, baliktad. So anyway, ako lang i-consider si point B sa analysis since akong yun na tanaw po ang internal, external forces applied because class, mingaw, di ba, diri nga side, sa right side sa to ang trust. So, sa analysis, mas mubo or gamay ang chances of error no? Kay wala ko'y daghan i-consider na external force. Unlike if ang imuhang plane would be in this way, oops, sorry. If ang imuhang cutting plane sa imuhang method of section would be in this manner, so di ba daghan ka of force or external loads i-consider. You have 15 kilonewton and another 15 kilonewton, no? So, ma-include na siya sa inyong analysis since you are analyzing man the left side part of your truss, no? So, sometimes class, ano lang na siya, graog technique kung asa ka mas madlay og solve or asa ka mas dili maglibog. So, if ganyan ka mag-analyze no right side part sa imong truss, mas dali gid siya no kay wala may external load nga na-apply din hin. So, meaning, kanilang ako ang concern yun, no? Kanilang internal load yun alone. And then, si RD. But, dili mabala ka pang reaction at point B since ma-obtain na naman nato na siya, no? So, dili na lang ako po i-obtain si AY and si AX, no? Since, in my approach, no, or sa ato ang solution, dili naman po na siya need niya data. So, dili na siya necessary nga i-solve ang reaction kang point A. Anyway, sige. So, let us solve for the reaction at point B. So, how do we solve for RD? So, summation of moment at point A equal to 0. Having counterclockwise as positive. So, what are the involved forces? No? So, the external forces as well as your internal, your reaction at point B. And that would be, so RD will create a positive, positive sign convention with respect to point A since it is, or it will cause counterclockwise no, with respect to point A. So RD times, okay. So actually, ang puti lang yun ani nga problem kasi is ang iyahang moment arm. Mura yun na siya actually. Kaya wala man gipang hatag, di ba? So wala tagi tagaan ng mga moment arm. So unknown ni siya. So di pa nato makompute sa RD. So unahon sa nato solve ang moment arm no per external forces. Sige, so wala tay moment arc or the whole span no sa imong atras. Wala siya gihatag. And then for 15 kilonewton na force, kani siya nga 15 kilonewton since that is just acting perpendicularly no sa imong member A to F and given no ang length sa imong A to B or A to F na member. So, may-utilize rin nato ni siya as iyahang moment arm. So, dili na siya necessary nga i-resolve pa nato into X and Y components. So, 15 kilonewton na force would be 3 meters no with respect to point A ha, ang iyahang moment arm. So, for 30 kilonewton na force, wala tay data no. So, ato ya po na siyang isolve. Sige ha, ito i-label here. So, padulong ta kang point A. And also, okay, so 15 kilonewton, wala siya moment arm. Si 30 kilonewton, wala siya moment arm. At we are about to find out ang pila iyahang moment arm with respect to point A. And then, si RD, no? So, kanipod. Akong ipang-red ang ato need na i-obtain nga data no? As well as si 15 kilonewton kanisya na force no wala po tayong moment arm niya so padulong kang point A or kang pin A so we need this data po no para compute na to ang moment arm ang 15 kilonewton na force. So, I will delete ay na lang. Ano na lang siya. We will leave it as that. Okay, so first, si 30 kilonewton na moment arm to ang pangitaon, no? And how do we do that? Di ba, we have this triangle. So, if this is point F, and then point A, so gihatag ang angle, no? 45 degrees kani siya nga member. So, siya nga member 45 degrees with respect to the horizontal ihang angle of inclination. So meaning also given po ang total span ani nga member, no, and that is 6 meters, diba? Para all 3 plus 3. So makompute day na to ang kani siya nga distance. Sige, ako siya i-label as x. Okay, this is x and y. So just apply trigonometric functions, no, or SOHCAHTOA. Ma-solve tayo na to ang iyang x and okay. There. So we can just solve, or we can just actually compute for these two unknown variables. So for x, we have here cosine function, no? So cosine of 45 degrees, okay, so katawa, so adjacent, no, si x over the hypotenuse na 6 meters. Therefore, x is just equal to 6 cosine 45 degrees, 4.243 meters. So, na tayo moment arm, no? Kang 30 kilonewton na force. So, for y naman, since this is just 45 degrees, no? They are just actually the same, no? So, the same value lang ato ang makumpani. But, ilang, ato lang yato siyang i-solve using the SOHCAHTOA na relationship. So, y is sine theta na function ng gamitan. So, sine 45 is equal to opposite na si y over hypotenuse na 6 meters. So, we have y here equal to 4.243 meters also. Okay? Sige. So, nakuha na to ang moment arm for 30 kilonewton na force. So, check. Next. So, mini class na ang kaning span sa imong truss. It will just be 2x. So, that will just be 2x, no? Symmetrical naman na sila. It's just that ang external loading ang di symmetrical. Okay. At, so, kanina lang siya. Kaning moment arm, no? Sa ito ang 15 kilonewton na force. Okay. How do we... Okay, let me add another blank slide. So, how do we solve for the moment arm of 15 kilonewton? It's just... Sige, atong i-drawing ang iyahang triangle, no? Na relationship. So, we will look at this relationship of any class. Wait, i-read na lang ako para mas klaro dyan. This one, and then kani siya, no? So kani nga triangle ato ang kuan o relationship. So So this is just perpendicular here and also perpendicular here. So you have 3 meters. So unknown, no? Ako na siyang i-label as, yeah, that's not actually necessary sa solution. So we need to compute for this one. Ako siya i-label as A to finally compute for this distance, no? Okay, at ako siya i-label as this is B na side and this is C. Ano na lang. So, kanya nga triangle ang ato ang kuhaan ang relationship. So, ato lang na siyang i-expand here para mas maklara na to. Okay. Sige. So, ganito siya, di ba? This is 3 meters. Mura man siya nga length class of 3 meters. Then, ABC. This is A, B, and C. Okay. So, ilan yung angle of inclinations, no? Okay. So, for kani siya triangle class, no? That is, diba, 30 degrees. That is just 30 degrees. Hindi horizontal man ang angle of inclination sa inyong number A to B. So, meaning, this is just 30 degrees. And then, kani po siya nga triangle, pila mo yung angle, no? At angle at point A. So, that would be 15. 15 only, no? Kay, mo man yung orientation class, oh. So, this is 30 degrees. And, your number A to F kay 45 degrees inclined pa doon na siya. Diba? So, meaning, ang kanilang siya alone na triangle, that is 15 degrees. No? 45 minus 30. This is 15 degrees. Okay? Sige. So, first, consider natin yung right triangle. So, di ba you have adjacent to the angle and hypotenuse ato ang gafaon na kay naraman ang right angle very class. So, hypotenuse si A. No? So, to do that, adjacent and hypotenuse, so cosine function ato ang gamitan. So, cosine 15 degrees is equal to adjacent na 3 meters all over hypotenuse na si A. Then, we have here, number A is equal to 3 over cosine 15. And how much is this? This is just 3.106. So, 3.106 meters. Ito ang number A. Okay? Now, na tayo obtain data, no, for this triangle. Kaming second triangle nga ito ang i-compute. So, na tayo hypotenuse, no, ani nga triangle. At makompute na nato ang si length B and si C. So, later you will find out nga nung ikapo na to si B. Hindi lang. So, to do that, trigonometric functions na diyapunta, no? So, from sa katawa, so, kaon na to si C. Kay, in this case, si C man ang ato asang sub-objective, no? Or isa ka goal pod para makompute na to ang moment arm ni 15 kilonewton na force, na external force. So, this is adjacent and hypotenuse. So, cosine function of 30 degrees is just equal to adjacent na si C over hypotenuse na si A, where A is 3.106 meters. Therefore, C is, kailangan na siya. So, 3.106 cosine 30. So you have 2.689 feet. So 690. So 2.690 meters. Sige. So for number B, so di ba sine function lang na siya, no? So sine of 30 degrees is equal to opposite niya si B over hypotenuse niya si A. Therefore, B is equal to 1.553. Alright. Sige. So now we have the necessary data to actually compute for the reaction at point B. So ato ni siyang, this is C. Naman ni siya si C. From point A to 15 kilonewton na force. And finally, makompute na nato ang reaction at point B. Wait, let me just add another slide. So, summation of moment at point A or at support at A equal to 0, having counterclockwise as positive. So, what are the forces involved? So, si RD times 2x, no? Yung moment arm is just 2x, and that will be positive side convention since it will cause a counterclockwise rotation with respect to point A. So, RD times 2x. Okay. So, kani, si 15 kilonewton, no? So, si 15 kilonewton times 3 meters, no? Iyahang moment arm. And 15 kilonewtons would cause clockwise rotation, di ba? With respect to point A. Therefore, that would be minus 15 times 3. Kasi 30 kilonewton naman. So, 30 kilonewton, diba, iyahang moment arm ikanin si x na length, which is na-compute na po nato. So, 30 kilonewton will create a clockwise rotation with respect to point A. Therefore, negative sign convention also. So, minus 30 times x. Since x iyahang moment arm, no? X. So, paman. Diba, you have si siya, no? Si 15 kilonewton acting at joint B. So, 15 kilonewton times moment arm na si C. And it will create negative sign convention, no? Since clockwise rotation na iyang makos. Minus 15 times CC, length C, equal na to 0. Kaya wala na may lain forces involved, no? So, sige. So, makompute na nato si RD, no? So, supplying the necessary data na ma-obtain nato, no, for X and CC, makompute na nato si RD. So, RD times, times 2 times X is how much? 4.243. Minus 15 times 3 minus 30 times X na 4.243, diba? Minus 15 times C. How much is CC? 2.690. Equal na to 0. Okay? So, in this equation class, isa na lang ato ang unknown variable. Therefore, makompute na nato ang reaction at support D. See, and how much is RD? So, we have here 15 times 3 plus 30 times 4.243 plus 15 times 2.690 all over 2 times 4.243. RD is equal to 25.058 kilonewton. Okay, so since we now have reaction no, at point B, sa galito ato ang approach. So, we'll now have to determine the internal reaction at member BC no, using method of sections. So, nanatay RD, no? Then, mag-moment ang point F. So, si force BC ang unknown sa ato ang system, no? And, makompute po nato siya directly. Okay. So, summation of makapy ba niya siya na FBD. Wait, ito siyang i-copy para alright. Diba? So, if mag-moment ang point F, ma-eliminate no? Si numbers FE and FC. So, si BC na lang din ang ato ang unknown variable no sa ato ang equation. Okay? Sige. So, summation of moment at point F equal to 0, having counterclockwise as positive. So, you have RD. So, RD with respect to point F will have a counterclockwise rotation, no? So, positive sign convention na ito ang consideration ng RD times moment arm. So, di ba this is point F and na-plus of the point F is just actually x distance, no? From point A and point B. So, that is just distance x. So, unsa kung may lain forces, di ba? Si BC na lang. So, BC will be negative sign convention, no? It will have a clockwise rotation with respect to point F. That's why negative BC times moment arm. Okay. So, wala tayo moment arm no, for member BC. Ato na siyang i-label as Y2. Kay, di ba, namatay set as Y, kani siya nga, kani, na-adring part. And, mo lang po niya actually ang ato ang basis. No? Mora po niya ato ang gamiton nga relationship. Since, di ba, we have this, kani siya nga triangle is, kaning color blue, ha? Nagsapaw-sapaw na class. No, di ba niya siyang triangle? Kani man siya. So, di ba, humano yung ato ang Y. Ako ising color para dili yung magliw. So, if muli ato ang Y, no, and ato ang objective is makuha niya siya nga length. So, ato lang ilas, no, si kani siya nga length, si B. Okay? That's why, ikuha po nato itong B, yung length earlier. Kaya magamit din nato siya dili. Okay? So, to compute for Y2, we just have to deduct length B to our length Y. Okay? So, we have this equation. Y2 is equal to Y minus B. Okay? So, na-compute na diba ng Y and also si B. So, makompute na nato si Y2. So, ako na siya i-indicate diri ha. Refer to sa Mandarin part plus given figure na lang. Page 1 na lang. Okay? Para dili mo maglibog nga no. Asa man na siya na equation gikan. Ni kalitra man na siya ito nga. Sige. So, naan na siya diri class ha. Dari mata na siya nakuha. Y is sorry. Y2. Ako na siya i-label as Y2. Y2 is equal to, sorry. Mo din ni si Y2, di ba? Kani siya nga less na height. Y2 is equal to Y minus B. Okay, klaro man siguro sa figure, no? Okay. Now, so BC times Y2 equal to 0. Wala na may laing involved, diba, na force. Sige, so RD is obtained, which is 25.058 times X. Pila ba itong X? 4.243. Minus BC, which is unknown. Then Y2 is, pila man na siya class? 4. Itong Y, 4.243 minus B. Pila ang B? 1.553, diba? So, Y2 is 2.69 meters. Equal to 0. Therefore, compute na nato ang internal reaction no, ang number BC. Okay? So, ito siya ato ang main objective for this problem para ma-compute na nato ang required area for the material at number BC. So, 25.058 times 4.243 minus BC times 2.69 equal to 0. So BC is how much you have here? 39.525. Okay, I'm sorry. Kilonewtons, no? And it is in convention, no? Tensile lang yung convention. Since positive man nato ang obtained na value for member BC. So, sakto ang atong assumption sa inyong internal reaction. Okay. Now, dali na lang rin kayo na to compute ang area, no? Kaya, mura man ni ato ang equation na gamiton. Kanina man, no? Allowable normal stress is equal to BC over A. So, normal stress is equal to BC or the internal force, internal action load, no, at number BC over the area of BC. Sige, so pila ka itong allowable normal stress? Di ba? 120 megapascal. So, I have here 120 megapascal is equal to BC, which is 39.525 kilonewtons. All over the required area na for member BC. So therefore, the required area for member BC would be, pila man siya class na. So that is just 39.525 times 10 to the power of 3 all over 120 times 10 to the power of 6. And that is 3.294 times 10 to the power of negative 4. Take note, this is in terms of meters squared, no? And ang ipangita is, di ba, in terms of millimeter squared. So, multiply lang siya by, so in 1 meter, you have 1,000 millimeters. Square na to siya. And that is 329.94 375 millimeters squared. So, excuse me for a while, class. Hang off your cell phone. Okay. So, okay. So, muna to ang final answer for situation number two. Therefore, the required cross-sectional area for member BC is 329.375 millimeters squared. Okay, so questions so far or clarifications? Nasabtan class? Or asa ka part naglibog? Okay, so I guess nasabtan ra ka? I hope so. Kay situation number two actually ang problem na majority of the students ang wala nakakuha, no? Anyway, sige, so let's have situation number three. So situation number three, actually, this is very easy lang yun. No problem, class, no? And if mutuo more sa dili, this is actually a board exam type of problem. So gikuha na ko na siya from board exam na problem. So situation three. Okay. So, di ba mo lang yato ang last problem no, nga asiran for today. Then, on Thursday, situation 4, 5, and 6 na pod. So, again, for situation number 3, you have the two wires are connected together at A. Then, if the force P causes point A to be displaced horizontally by 3 millimeters, determine the normal strain developed in each wire. So, actually, equal lang ang ma-develop nga strain, no? Or normal strain, no? For both wires since it's just symmetrical man. Okay, sige. So, di ba, ingon sa problem na force P will cause point A to displace by 3 millimeters, no? So, from this point, the original position of point A until, let's say, at this point, auto lang siya i-label as A prime. So, na-displace daw na siya na by 3 millimeters. So meaning, ang ato ang tip sa ato ang wire AC would be at this point ano siya ka point A prime. So hiwi ka siya no. So assuming nga straight na siya ha. So di ba you have this illustration na dayon. So ang gipangutana is the normal strain not in each wire. And unsa gali tong equation nato or formula for a normal strain, di ba? It's just length over, I'm sorry, this is deformation, no? Deformation over the total length or elongation. This refers to elongation over the original length sa imuhang wire. Okay? So, meaning, we are to determine the elongation of both wires and then ang ihapong original length, no? Kay wala man gihatag pud sa problem ang original length since ang gihatag laman nga data is 300 millimeters daw no from this wall or from supports up to point A. So given that relationship maka-create og triangle no. So gamit jud kaayo ang trigonometry actually class no. So as you can see most of the time ang ato yung preliminaries or ato ang first steps ato ang mga solutions involves trigonometry jud class. Okay? So this is 30 degrees, di ba? Kanilang man na siya oh. 30 degrees and then this is 300 millimeters. Okay? Sige, ako na siya i-label as L. No? The original length of your wire. Sige, so how do we determine L? So, by cosine function, no? So, cosine 30 degrees, you have adjacent nga 300 over hypotenuse nga si L. Therefore, the length or original length of your wire is equal to 300 divided by cosine 30 degrees. And that is 346.410 millimeters. Now, ato po i-determine ang elongation no sa imuhang wire. So, how do we do that? By using this triangle. Kani siya, no? Atong i-colora na to siya, color blue. Kani siya, class, no? So, kani siya, dili na ni siya kuan class, right triangle, no? Since wala may right triangle ana. I mean right angle. Wala may right angle ana. So this is not a right triangle, Meaning, dili na to ma-apply ang SOHCAHTOA. Kay SOHCAHTOA is just for right triangle man nga concept, di ba? Sige. So, wala punta kabalo sa angle diri, no? Kay ni acute man na siya. Ni gamay kibali ang angle. So, ato ni siya i-label as L prime. Then, mo ang original length, no? Kanira man na siya class, oh. Nara siya. So, if this is L prime, then you have L here, and given ang base, no, sa triangle, which is 3 millimeters. Ma-compute actually na to ang angle, no, at this, since that is just supplementary, no, of 30 degrees. And how much is that? That is 150 degrees, diba? So, 150 degrees angle ang imuhang point A. Sige. So, given pod ang L, no? Na-obtain naman na to ang L. So, ato lang siyang gamiton nga data, no? So, this is 346.410 millimeters. So, you have two sides, no? Then, one angle, included angle. So, magamit na to ang cosine law. Diba? We have sine law and cosine law for triangles that are not right triangles. So, by cosine law, diba, we have, sa gato equation, you have c squared is equal to a squared plus b squared minus, this is 2ab cosine the included angle C, or in this case, C 150 degrees, no? So, C squared, that would be our L prime, no? Okay, so substituting the datas, L prime squared is equal to A squared is either of the sides. So, you have, say, 346.410 squared plus b squared, so si 3 millimeters squared minus, okay, minus 2, a is 346.410 times b, si 3, no? Cosine 150 degrees. Okay, so I hope na masabtan ra, no? Wait ha. $150. Okay? Therefore, makompute ra na to ang L prime, no? So, dili na ako siya isulat. Therefore, L prime is equal to, it's just square root of 346.410 squared plus 3 squared minus 2 times 346.410 410 times 3 times cosine 150 degrees. Okay, so you have L prime equal to 349.001. Sorry, 0111 millimeters. Okay, so we now have the total length sa to ang wire, no, if na-elongate siya. So, makompute na nato ang normal strain. Sige. So, therefore, normal strain is just equal to the elongated length of your wire. So, L prime minus the original length niya, no, over the original length. Since ang ating elongation here, no, this only refers to the elongated part. So, dili na siya ang total length sa imuhang member if na-elongate siya. It's just kato lang yung na-expand ba no na part. That's why atong gila sa iyahang original length to compute for the elongated part sa tuang wire. So how much is this? Diba this is 349.011 minus the original length nga si L nga 346.410 all over 346.410. So elongation for both wires would be equal to 349 minus 011 minus 346.410 all over 346.410. You have 7.508 times 10 to the power of negative 3. No? So, unitless man siya, no? Or you can have it as mm per mm actually. No? Sige. So, if ato siyang i-express as decimal point, pila man siya? You have 0.007508. Okay? Sorry. 751 na lang, no? So, this is now our final answer for situation number 3. So, questions so far or clarifications? Okay, so I think what siguro yung question, no? I just hope na nasabtan, no? Ang ato ang situation 1, 2, and 3 sa itong midterm exam. Anyway, let's have your attendance. So say present if you are here for a while as a